Have you ever stopped to think about the journey electricity takes to get to you? I mean, it's a wild ride, traveling over hundreds of miles, and the whole thing is only possible because of one simple, absolutely brilliant invention. Today, we are talking about transformers, the true unsung heroes of our entire electrical world.
So let's start with a simple question. We all know you can't just plug your phone charger directly into one of those massive power lines. But why not? The answer to that question uncovers a huge challenge with electricity and introduces the hero of our story today. All right, here's how we're going to break it down. First, we'll look at the big problem early electricity was up against. Then, we'll meet the elegant device that solved it, dig into the really cool science of how it works, see how these things literally build the modern grid, and finally, take a peek at how they hold up in the real world.
Okay, let's go back in time for a second. It's the late 1800s, right at the dawn of the electric age. And there's a major roadblock.
The very first power systems, like the ones Thomas Edison built, used direct current, or DC. And they had one massive limitation. They were local, super local. If you wanted power, you basically had to live within a mile of the power station. Why? Because sending that kind of electricity over long wires was just incredibly wasteful. Most of the energy literally just fizzled away as heat. Electricity was basically trapped in its own neighborhood.
So, how did we break electricity out of that trap? We did it with a device so clever and so effective, it helped alternating current, or AC, win the famous War of the Currents and, no exaggeration, build the world we live in today. So what is a transformer? Well, it's a beautifully simple device that does one thing. It changes the voltage of alternating current. It can make it way higher or way lower. And that one single trick is the key that unlocks our ability to send power over vast distances. And, the design itself is it's shockingly simple. There are no moving parts. It's just two coils of wire, a primary one and a secondary one wrapped around the same chunk of iron. That's it. That elegance, that simplicity is exactly what makes it so incredibly reliable.
So the transformer really has two key jobs. First, a step-up transformer boosts the voltage way up high. This makes it perfect for traveling long distances efficiently. Think of it like shifting your bike in high gear to cover a lot of ground fast. Then, on the other end, a step-down transformer takes that high voltage and brings it way down to safe, usable levels for our homes. That's like shifting back into a low gear for control.
Okay, but how does it actually do that? I mean, how can two coils of wire that aren't even touching each other change the voltage? Well, the answer is one of the coolest principles in all of physics, electromagnetism.
It all starts when alternating current flows into that first primary coil. Now, because the current is constantly switching direction, that's the alternating part of AC, it generates this pulsing, constantly changing magnetic field all around the wire. This is where that iron core becomes absolutely critical. It acts like a superhighway for that magnetic energy. It grabs the magnetic field, concentrates it, and guides it perfectly from the first coil right over to the second one, losing almost nothing along the way.
And here comes the magic. As that moving, pulsing magnetic field flows through the second coil, it gets the electrons inside excited and actually creates or induces a brand new electrical current. So think about that. Electricity in the first coil became a magnetic field, which then became electricity again in the second coil, and they never even touched.
So how do you control the voltage? It all comes down to the number of times you wrap the wire around the core. It's a simple ratio. If the second coil has way more turns of wire than the first, the voltage gets stepped up. If it has fewer turns, the voltage gets stepped down. It's just a beautifully simple and predictable bit of math.
So now that we know how they work, let's zoom out. Let's see how this one device is the building block for our entire power infrastructure. It's a massive, coordinated system that gets electricity from where it's made all the way to you.
Okay, so it starts at the power plant. A giant step-up transformer boosts the voltage to hundreds of thousands of volts. This lets the electricity zip across the country on high-voltage lines with hardly any energy loss. Then, it hits a local substation, where a step-down transformer lowers it for your neighborhood. And finally, a smaller transformer near your house brings it down one last time to the safe voltage you use every single day.
And this shows you just how different the scales can be. On the left, you've got a massive, heavy-duty three-phase transformer. That's the workhorse for moving huge amounts of power. On the right, a diagram for a smaller auto transformer. That's more of a precision tool, used for fine-tuning voltage levels in a local area. They both work on the same principle, just built for very different jobs.
Now let's be real.
In the world of engineering, nothing is ever 100% perfect. And while a transformer on paper is a lossless device, in the real world, you do have to deal with some small but unavoidable energy losses.
So where does that energy go? Well, it mostly escapes as heat. You get what are called copper losses, just from the natural resistance in the wires. And then you get these other losses called eddy currents and hysteresis from all the magnetic weirdness happening inside the iron core. It's exactly why transformers sometimes feel warm to the touch and need cooling fins.
But here's the amazing part. Even with those tiny losses, a modern power transformer is one of the most efficient machines humankind has ever built. We're talking regularly over 99% efficient. Almost all the power that goes in comes right back out the other side. That's just an incredible feat of engineering.
So the next time you flip a light switch, just take a second to think about the transformer. A simple device of wire and iron, humming away silently somewhere, stepping voltage up and stepping it down, literally making our entire way of life possible. And it really makes you wonder, right? What other simple, world-changing inventions are hiding all around us, just in plain sight?